Hi, and welcome to this video on using multivariate statistics. I'm Kristen Kinsevich, and I'm a doctoral student at Regent University. I'm going to be talking through a process for running MANOVA and MANCOVA analyses, and we'll be following along in Chapter 7 of Using Multivariate Statistics. I have the 5th edition, so page numbers and table numbers and section numbers will correspond with the 5th edition. It's by Barbara Tabachnick and Linda Fidell. This 5th edition was from 2007. So we are going to be going over their complete example of both the MANOVA and the MANCOVA, because you actually need to run both analyses in order to really have everything you need for the MANCOVA. So that is section 7.6, and it's on page 277 in the 5th edition book. I think the 6th edition drops the 7 in front of the section numbers, so it might just say section 6, or 6.1 begins with evaluation of assumptions. So look for their complete example and you'll find the spot. And also the checklist of things that we're going to need for the MANCOVA is in table 7.33. I think in the 6th edition it might be just table 33. In the 5th edition, that's on page 303. And that just gives us kind of a checklist of all the different things that I will go over. But first, I wanted to just talk a little bit in general about the MANOVA and MANCOVA, because really being good at research is being good at wondering the right things. And so it's important to really think about what these analyses are telling us. And really the easiest way to think about it is we're looking for differences between two groups. And then when we find differences, if we find anything significant, then there's a second step of where do those differences lie. And so that's really the point of the MANOVA and the MANCOVA. Of course, it analyzes for differences in variance. And just as a refresher, the differences between the ANOVA, ANCOVA, MANOVA, and MANCOVA. Remember that the ANOVA, a one-way ANOVA, is simply one independent variable or factor and one dependent variable. So, for example, that might be if you were looking at test score differences based on level of education. Level of education might have 3 or 4 groups, and you'd compare the test score differences, not the means, but the variances between those groups. A two-way ANOVA would have 2 factors or 2 independent variables, maybe levels of education and personality type, and you would still be looking at one dependent variable, such as test scores. For ANCOVA, you would have one dependent variable as well, and you would have one factor or independent variable, so let's say test score by level of education again, but this time you would add a covariate, so you would have let's say the number of hours spent studying, and you would control for that. If that was the same for everybody, what would the test scores be based on their level of education? So it's kind of removing one bit of the data by trying to figure out if everyone were equal on that one covariate, then what would the test scores by level of education look like? So that's the ANCOVA. The MANOVA then is looking at an independent variable and 2 dependent variables or more, 2 or more. That's the one-way MANOVA, so it's one factor or one independent variable and multiple dependent variables. And then a 2-way MANOVA has 2 factors or independent variables, and then 2 or more of the dependent variables. And then for the MANCOVA, you have 2 or more dependent variables, 2 or more covariates, and 1 or more independent variables. So for that example, you might look at the level of education as an independent variable and compare the groups on test scores and annual income as dependent variables, controlling for a covariate of the hours spent studying. So I hope that makes a little sense and is a good review of what all these different tests are for. They're really all very similar, as you can see, but it just depends on how many dependent and independent variables you have and whether or not you're controlling for covariates. So for this assignment, now back to Tabachnick and Fidell, we're looking at this research question for the MANCOVA. Do self-esteem, introversion, extroversion, and neuroticism vary as a function of sex role identification after adjusting for differences in socioeconomic status, attitudes towards women's role, and beliefs regarding locus of control? So you see there's the three dependent variables: self-esteem, introversion, extroversion, and neuroticism. Those are all on scales, continuous. And then you've got covariates of socioeconomic status, attitudes towards women's roles, and beliefs regarding locus of control. Those also are on scales, so I'm not sure quite how they did the socioeconomic status, but it's not in groups, it's on some type of continuous scale. And the sex role identification is these two scales, masculinity and femininity, and their interaction. And this ultimately is going to give us 4 categories or possibilities. That's why it's called a 2x2 MANCOVA, because you can either be high on the masculinity scale or low on it, and you can be high on femininity or low on femininity. That gives you 4 options. If you're high on masculinity and low on femininity, then they're calling you masculine. If you're high on masculine and high on feminine, they call that group androgynous. If you're low on masculine and high on feminine, then you're feminine. And if you're low on masculine and low on feminine, they called it undifferentiated. This is a sample of all women from the 1970s as well. So regardless of what you think about gender identification and sex role identification, you do have to keep in mind this was from the 1970s. So some of that might need to change if you were going to repeat the study for today and trying to get equivalent results. So here we have on the screen the MANOVA, and this website is goes along with the book, and it has the data sets that go along with the Tabachnick and Fidell book. And so if you don't already have it, the MANOVA data set is right there. And also on this page, you will see something that they refer to in the book. There's 2 things. One is this non-CF.SAV. The other is the non-CF3.SPS. They're going to refer to those when they're talking about effect size. If you were to open up this SAV, it's an SPS file, and then this .SPS is an algorithm that computes effect size. I could not figure out how to actually run this myself, but the book describes that with giving the results of each of those calculations. And so I just went with typing up what the book had to say and explaining effect size. So if you can get these 2 things to work, that is what they're talking about in the book. But if you just want to follow along in the book, that's what I did. All right, so let me open up the data set. And as you can see in our variable view, we have femininity, masculinity. This top one here, the 4 groups, that has already labeled our data so that each case is labeled in one of those 4 groups based on how they scored on the masculinity or femininity. You can see here that it's low or high are the options. Same with masculinity, low or high. So they're put into categorical groups. We don't actually see the scale numbers there. And you can see here the 4 groups I was talking about based on whether they were high or low in the femininity or masculinity. We'll need that in a minute, but let's look at our other variables first. So this is self-esteem. And I do want to point out that it appears, based on what Tabachnick and Fidell describe, that for self-esteem, if you get a lower score on the self-esteem scale, then it means you have a higher level of self-esteem. So if that's a little bit confusing later on, particularly when we get to the very end, just remember that a low score is good on self-esteem. And locus of control determines whether they have more of an internal sense of control or an external sense of control. This at-role variable is the attitude towards the role of women. SEL2 is the socioeconomic level. Int-ext is introversion, extroversion, and neurotic is neuroticism. So that will help you as we go along to remember and understand which variables they are and what they measure. So the first thing that we're going to do is our assumptions testing. And actually, we really have a few different kinds of tests that we need to run. I think it ends up being 1, 2, 3, 4, 5, 6, 7, 8. I believe we are going to run 8 different outputs. And so we'll just go through them one by one. The first one, we're going to keep the full sample. We're not going to split the data file but based on those 4 groups of femininity and masculinity yet. We're just first going to pull the histograms. These are univariate histograms, but here when we're looking for sample normality, we're not looking for the normality of the scores, but normality for the sample. But univariate histograms can be one way that we support the idea that the sample means are normal. And so we're going to go ahead to descriptive statistics and frequencies. And then what we're going to do is just choose all of our variables and covariates, so the DVs and the CVs, so everything except for masculinity and femininity, all of our continuous variables. So we just put them all over here, and what that's going to do, we don't need to display the frequency tables yet on this one. That will give us so much. Oops, I need to click on something else first. Okay, so now what we want, we don't need any of these things quite yet. We just really want the histograms for this particular part. We're going to run a different frequency output in a minute with the file split. So for now, just click on histograms and show normal curve on the histogram. Click on continue. That's all you'll need, and then make sure this is turned off or you'll get a whole long output. Then you can click OK, and let's see your output. You're going to have your histograms on each of the covariates and dependent variables. Now, one thing you'll notice here is that there is one missing case, which we'll see when we run our split file frequencies too, but you can see on locus of control there's one missing. So first, let's just save our output, get in the habit of that, and let's just call this MANCOVA output. Save. Okay. So now we'll just keep remembering to save, and we're going to go ahead and look for that one case on locus of control. But actually, what we can do to make our lives a little easier, we could search through all 369 cases, but we can also narrow it down when we run our next frequency and see exactly which group they're in, and that might help us find it. So what we'll do just right now is look at these histograms. You see that those shapes are real nice. And you can also look for univariate outliers here, which there are none. Everything fits really nicely within the bell curve. And so we don't have any univariate outliers, so we can check that off the list. All right, let's minimize the output. And now we're going to go to Data and Split File. And what we're going to do is organize the output by the groups. And we're going to have the groups based on these 4 groups they've already created for us. Everybody's already in a category. And so, and it's going to sort it for us. So it will put it right in order for us. That will make our missing data easier to find. So we can click OK on that. And then that doesn't give us any different output other than it tells us what we just did, sort cases. So we can just hit save again, because that's always a good idea. And can you tell I like saving things? All right, so now we have to hit save on the data set as well, because we just made a change. It split the file, so it's going to organize our output by those 4 groups, which we'll just need for the frequencies and looking for multivariate outliers and collinearity. After that, we'll unsplit the file. So what we need to do is run another frequencies now that we have the file split. So we click on Analyze, Descriptive Statistics, and Frequencies again. This time, we do want the frequencies tables, although I'm not sure, because we already know that there are no univariate outliers. I'll do it for now, but you probably don't need to. It just makes your output longer and kind of more to look at, but we can leave it on there. I don't think we'll actually really need to look at that part, though. What we do want in statistics is the mean, and I think really all we need to know is skewness and kurtosis, but we'll go ahead and click on all the normal things. Okay. And charts, we don't need any histograms or anything, because we know that they're already as a whole good, so we don't necessarily need to look at that anymore, although it's already checked off. But that's going to give you 24 different histograms, so that's a lot. So we'll just undo that and hit continue. We don't need any of that. All right, so then let's hit OK and look at our output. Now we can see our frequency tables and all of our statistics. So let's go up here. Now it splits it up for us as well. And so, as I said, all these frequency tables are kind of unnecessary for us because we know we don't have any univariate outliers. What we are looking for right now is missing data as well as within cell skewness. That means within cell just means for each group. So here where we have our statistics, the first group that we have is the undifferentiated group. That one was low on masculinity and low on femininity. And so we also want to pay attention to this number here. That's the N for each group. So there's 71 cases in the undifferentiated group. None missing here, so we know that there's one missing somewhere on the locus of control, but we don't know where yet. Let's take a look at the skewness while we're here. Now, close to 0 is good, and so that's a good skewness number right there, so no problems there. And we can skip down here. See, I shouldn't have looked at the frequency tables or checked that box off because it's it's just more in the output, but it doesn't matter. Next, the feminine group. Okay, here we go. We found it. The missing locus of control is in the feminine group. So we're going to go back to our data set in a minute and delete that case. And so this is the N that we'll have for the feminine group is 172. So a pretty large percentage of the sample was high on femininity and low on masculinity. Maybe not surprising of a group of women, but and in fact, that is why they decided to weight femininity more heavily than masculinity in the various tests that we're going to run, because they felt that it was kind of a reflection of something real in the population. So even though we have unequal cell sizes, here's the masculine group, it's only 36 compared to 172. That's actually not the greatest ratio. It's more than 4 to 1, which we don't like to see, but we can account for that with normality and collinearity. So they went ahead with that. And also the reason that they're okay with it is that 36 is well above the minimum of 20 if you have unequal cell sizes. So that's another reason that we're okay with proceeding with the analysis. All right, for this last group here, N is 89. So I made a little chart that had, the kind of 2 by 2 with each of the 4 groups and how many were in each group. Just helped me to kind of see what they looked like. So I think that's it. That's all we need. And because we didn't have any univariate outliers, we already knew that from our histograms. We didn't really need to look at these frequency tables. Okay, so, oh yeah, the skewness, I did that on the first group and then I forgot to look at it for femininity. So we did it for the undifferentiated group. Here's feminine. Let's see, the skewness, 0.471. Yep, so that's good. So this is the within cell skewness that we're looking for here. Let's go down to the masculine group, scrolling down. Okay, skewness, 1.316. All right, that's a little higher, but it's also still not too bad. So the book does say that that's fine. Closer to 0 would be good, but I think in the last assignment, or in chapter 6, the skewness, some of them that were off were up to 6 or 5 or 6, something like that. So it was pretty high. So 1.3 is okay. And then the last group here, the skewness, 0.402. So we are good on within cell skewness. We have the N for each group. We know that there is univariate normality and there's no univariate outliers. And we know that we have missing data on in the feminine group for locus of control. So let's go back to the data set. Now they did put it in order for us. All the 1s are first and 2s and so on. So we know the undifferentiated was the first group listed. Femininity is the second group listed. So somewhere in this where they have 2s, there's going to be a missing locus of control. So let's just scroll down with our arrow in the control variable here, and we will eventually run across it before we get to any 3s. So let's just keep looking. There's a lot of 2s. It's the biggest group. Okay, here we go. Here is our missing data cell. So that is on line 172. It's case 1810. And we're just going to hit delete. There we go. Now it's gone. And we can save that. We don't need that case. And now we're ready to do the rest of our analysis. So before we unsplit the file, we also want to run a quick regression with a dummy variable to test for multivariate outliers and also look at the collinearity diagnostics. So these things should feel familiar if you've done the chapter 5 or 4, I guess we did the data screening, and then chapter 6 was the previous assignment that I went over. So if we go to Analyze, Regression, and Linear, we can pick this case number as the dependent variable. That's our dummy variable, and so that doesn't matter at all. It's just what we really want is to look at the combination of all the different CVs and DVs. So we're going to just put all 6 of our continuous variables on here. We're looking for multivariate outliers, And if you recall, the way that we find the multivariate outliers is by editing the syntax. So we're going to add the little line that tells it to show us the outliers using the Mahalanobis distance. So first, in statistics, we click on that, and we want the collinearity diagnostics. So click on that. I didn't notice this before, but covariance matrix is here, and I know that's something that we're going to talk about in a little bit. So I don't know what's going to happen if I click on that, but that I'm going to just see what the output looks like in that. I'm going to hit continue. And now, let me see, options. No, we don't need any of that. Okay, so we don't need anything else. What we have to do is click paste because we have to add the line to get our multivariate outliers residuals tables. So I'm going to click paste, and oh, I already have a syntax editor open, and so here it is. And yeah, I'm going to add to that later. So we want to erase the period, click enter, slash, and then I think we wanted to do residuals. Yep, residuals equals, and then here we have outliers. If you kind of don't know the syntax, or you like kind of remember it, but maybe you don't remember the whole thing, it gives you options when you check on things. And we're going to put Mahal in parentheses and a period at the end. So that's going to give us our outlier charts. So we're going to click back up on here on regression and hit this green triangle. That's going to run just this little part of the syntax. So we'll run it and save it and minimize. Then we got to open up our output. Here we are. Okay, so here's the regression. And what this is showing us is our collinearity diagnostics and our multivariate outliers. Now, the book did tell us the chi-square critical value. And let me just look that up so I can make sure I tell it to you correctly. On page 280 of the 5th edition, which it's in section 6.1.4, outliers, it does mention the critical chi-square value of 22.458. So we're looking for any in the outliers tables that is higher than 22.458. And we're also going to look at the collinearity diagnostics. Here we have some collinearity statistics, and you can look at that if you want. I don't remember what the tolerance levels are supposed to be, so I didn't use that one. This is is this the covariance matrix? Just curious what that would look like, but I don't think that's important for us. What we really want here is this collinearity diagnostics chart. This is the one that you want to look at. And if you recall from the previous chapters, the condition index should not be more than 30, and any values that approach 30, you look at the 6 variables and make sure that there's not more than one that's higher than 0.5. So here in this one, now this is just the undifferentiated group. We're going to have 4 of these to look at, but it does show us here that we're okay for within cell linearity. So now we're going to go down and look for the outlier statistics. So remember 22.458. Nope, that's fine. We're good. So no outliers so far. Here's the feminine group and collinearity diagnostics here. Yeah. Okay. Sorry, I'm just trying to remember something, but I can't. So we'll go with this. All right, again, 28 is approaching 30, but let's look here at the different variables. None of them are over 0.5, and we could get away with one of them being over 0.5, so we're okay. Outlier statistics is 22.458, so that's all good. No multivariate outliers there. Here is another collinearity chart. 28, again, we're getting close. And here we have a 0.69, but none of the others have a 0.5 or higher, so we're still within the acceptable limits. And here in the androgynous group, we have collinearity diagnostics here, again, pretty close to 30, but we just have one that's more than 0.5, so we are okay in that row. So the collinearity is okay, that assumption is met, and again, no multivariate outliers in this group either. So let's just hit save on our output, and we are all set. We have no multivariate outliers, and the collinearity looks good. So we're going to look for multicollinearity later, but that was just the within cell collinearity. So the reason I was pausing is because I'm not sure if we actually needed that or if the multicollinearity kind of covers it for us. They do have a little section 7.6.1.3, or for the 6th edition, that might just say 6.1.3. It does have a little blurb about linearity, which is frustratingly brief. And it does say that we could do scatter plots if we needed to, but they're encouraged by the balanced distributions that we found. So they say we really don't need to worry about linearity in that case. So you can decide whether or not you want to pay attention to the collinearity diagnostics, but there you have it. So now we're going to minimize our output again. And this time we're going to unsplit the file. We don't need it split anymore. So we go down to Data, Split File, and we just click on Analyze All Cases and click OK. So that's just going to take us out of our output, splitting it up into 4 groups. And we can minimize that and save our data file. Okay, so now we are ready to examine one more of the assumptions, which is the homogeneity of regression. And this is going to require you to type in the syntax that they show. In the 5th edition, it's page 282. And also we're going to have to do a second one, which is page 283. It's table 7.13, or maybe the 6th edition might just say table 13, and also table 7.14 or table 14. It's a doozy, and there is no way to use the menus to do this. You have to type it in exactly as it is. And the reason for that is because we want to do a step-down analysis, which means we want to eventually look at each of the different dependent variables, not just controlling them for the covariates, but also controlling certain dependent variables based on some of the other dependent variables. So the prioritization is based on the significance levels that we're going to find, but ultimately those step down, basically we want to make sure that all of the different combinations of variables are have that homogeneity of regression, which is their regression lines would all be parallel to each other. So you may want to pause right here and type that in. I'm just going to show you my syntax. Now we have the regression we just ran here, but up above, what I've done is this I put a little line in here when I save my syntax so that I can remember what it did and what was it for. So I just kind of put a line that's separate from everything, and make sure you don't have any, like I didn't type the word regression because I didn't want to be confused and think I was trying to put a line in there. So I just abbreviated it. But this is the table 7.13, and you can see you just have to type it in for each analysis, and it shows what the different things that it's controlling for are. And so then it starts, when you get into this pool, it is combining these variables, and then it combines the next 3 and the next 4. And so it's kind of this, you can imagine it is like steps where it kind of ends up controlling for all the different factors that could be possible. So if we go up to this, once you've typed that in, can hit pause, and then once you type it in, come back. And now if you're back, we can go ahead and click just where the cursor is flashing at the very top where it says MANOVA, and we're going to just click the run selection. And then we have to minimize that and go to our output. And here we have the very first MANOVA, but again, it's not our main analysis yet. This is just looking for the homogeneity of regression. Now, the things that are important for this one were actually, this is the one that looks at the covariates in addition to the DVs. So we want to pay attention to the very last step. So you can kind of ignore all of this top stuff until you get to the bottom. Okay, so we've scrolled all the way to the bottom of our output, because this is where essentially everything has gotten added up all together. Everything is down at the bottom here. We've got the socioeconomic level and all of the different covariates and dependent variables and femininity and masculinity and the interaction of those. Every possible combination of everything is within this bit of the ANOVA, which is really, it must be kind of a regression in a sense, because it's looking for the homogeneity of regression, but I might be saying that wrong. Ultimately, this is the only number we want to look at right here, this 0.118. Fortunately for all of us who don't want to spend any more time on statistics today, it is not significant. So woohoo, we are good. So as far as the covariates are concerned, we have homogeneity of regression. Hit save on your output, and then we can minimize that and go back to our syntax. And now what you're going to want to do is type in table 7.14. It's going to give us an overall homogeneity of regression. We need this for the MANCOVA and also the DVs. So that's what we're looking at. It's a slightly shorter syntax here because it doesn't end up controlling for all of them in all those different steps, because it's already controlling for the covariates all at once. And so it just pools the other two covariates, I think. I'm sorry, it pools the next level of the dependent variable and then the covariates, and then the two dependent variables plus the covariates. So it controls for all of those things kind of one step at a time. So you see this analysis first is esteem, introversion, extroversion, neuroticism, and then the introvert extrovert controlling for esteem, and then the neurotic controlling for both. So again, you might want to pause right here, type in that syntax, which I think because we did this regression first and we added this line, that's kind of actually really helpful because you have a syntax editor open already. So hopefully that was helpful in the first go around. And if you were confused and missed that, you can always go back and say, oh yeah, I have a syntax editor. That's how I get to it. So you just type in what's on in table 7.14, and now we'll go ahead and run it. So if you've gotten it typed in, we will put the cursor right at the top of it and then hit run selection. And we're going to minimize that and open up our output again. And we have a new one. And so you see here where it just says we're looking at the 3 dependent variables. Again, we're just looking for homogeneity of regression. We haven't gotten to our mean analysis yet. We want to look for the overall test, which is this top box here. Again, the bottom line of this top output, 0.596, thankfully is not significant, so we are good. And then it's going to go through all the different steps that we told it to go through, but we're just going to scroll all the way to the end. The very last thing that we need is, because this is neurotic, and that has all of the different DVs and CVs in here, so that's why we only need to look at that one, because it has every possible combination built into it. And so we can look at the significance on the last line here, which is 0.124. And again, not significant. So we have homogeneity of regression. So we are good to go. So I think that that covers all of the different assumptions. Just going to take a glance. Oh, the other thing you might be wondering and screaming at your computer saying, Kristen, you forgot the homogeneity of variance, covariance matrices. What on earth is that? We are going to find that out shortly. That's going to be in our first MANOVA, which, by the way, they call an omnibus MANOVA. That just means the first one you do. So we're going to get to that in a second. But we talked about linearity and homogeneity of regression for the covariates and the DVs for the step down. Oh, the reliability of the covariates is something that is kind of a more logical type of assumption, where basically you just want to figure out, is it likely that your data would be accurate and reliable, where the person would answer the same way. Generally, if you ask them, the same question, they'd give you the same answer multiple times. And that is assumed to be reliable because the questions are pretty straightforward. The scales are straightforward. And the multicollinearity and singularity. Now hold on one second, because I need to find where we found that. Oh, that's coming up too. Okay, singularity, we won't, again, that's another logical one. There's not a test that we're running for that. Singularity is saying, are any of the dependent variables kind of two parts of the same thing? So if we had like split, let's say, self-esteem into like 2 scales, we couldn't really have 2 DVs that were measuring 2 parts of the same thing. But we have singularity because each dependent variable and covariate is just measuring one thing. So that's, again, you can type that up. That's kind of a logical thing. The multicollinearity we are going to get in a minute, along with our homogeneity of variance covariance matrices. So that's why we actually need to run the omnibus MANOVA before we do our MANCOVA. So let's minimize the output, and we are going to put in, okay, hold on. I'm going to turn my paper over so I see what we're doing. Okay, so now we are still in the full sample. We're not going to split the data file anymore. And what we're going to do is go back to our syntax editor, because what we need to run is the MANOVA. Here's our syntax editor. Okay, so the MANOVA, here's where I labeled omnibus MANOVA. So here I know it's this one. Okay, this is the syntax that they have, and let me get you a page number. This is in, okay, it's on page 285 in the 5th edition. It's in section 6.2 or 7.6.2, and it's the MANOVA in table 7.15, or maybe the 6th edition would be table 15. So you see there at the top of the table, it has the MANOVA, and it has this syntax that I just typed into here. And so it's exactly as it's written in the book. So take a moment to type that into your syntax editor, and then when you're ready, make sure your cursor is right at the top of that one and go ahead and hit Run Selection. We will minimize that and open up our output. And here we have a new MANOVA. Now, this is still not really our main analysis because we're going to be doing the MANCOVA. We want to adjust for the various covariates. And right now, this MANOVA is actually treating it as if we have 6 dependent variables. So the covariates are kind of all lumped together with the dependent variables. And so that is, you can see right here, a lot of this you can skip. We are looking for boxes M because that is going to tell us if we have multicollinearity. And so, I'm sorry, that's going to tell us if we have homogeneity of variance and covariance matrices. That is the boxes M test and also the Levine statistic. They do say that the boxes M test is really sensitive. Fortunately for us, we are good on that because the P levels here in the boxes M are not even close to significant. So we do have homogeneity of variance, covariance matrices, and we're good to go. The multicollinearity comes with these within cell correlations. So that's another thing that's on the list on page 303 or in table 7.33, or in the 6th edition it might be table 33. You see 2A is within cell correlations. So that's going to be from this analysis here, and it's right here on the screen, this little diagonal line. Those are the various correlations. And so you can see, obviously, esteem is going to be correlated with esteem, but then it shows the correlation between the attitudes towards the roles of women and esteem, neuroticism and esteem. Sorry. I just was trying to get rid of that box. Okay, here we are. Introversion, extroversion. Again, it's high with itself. That makes sense. Control, locus of control and esteem here. That's their correlation. Locus of control and neuroticism. That's the correlation there. And then socioeconomic. So the things that are of interest is this correlation here between neuroticism and self-esteem. And then also locus of control and self-esteem, and then also control and neuroticism. Those 3 added together make up about 10% of the explained variance. And so that is something that in their little example of a results section, they do reference. It's the pooled within cell correlations. And it just shows that the combination of esteem, self-esteem, neuroticism, and control, locus of control, that combination of variables explains 10% of the variance. So that's going to go in more of your main analysis section. But one more assumption we haven't covered is the multicollinearity, and that is this number right here that you're going to want to look at, the log of the determinant. So what that means is if you were to kind of essentially do the reverse of a log, it would be 10 to the negative 0.43360 power. If you type that into a calculator, obviously the negatives cancel out, and so what you end up with is a number that is 2.71. So that is your determinant. That value is significantly different from 0. It's enough away from 0 that we can assume multicollinearity. So that is what you would want to explain, is you're taking the inverse log and 10 to the negative 0.43360 power, and then that's 2.71. So that determinant is far enough away from 0. So we're good on all of our assumptions now. And now we can do our actual real analysis of the MANCOVA finally. So let's save our output and minimize that. Again, we don't need to go back to the data because we can't really use the menus to do what we want to do. The step-down analyses are not possible with the basic SPSS menus. So we have to go back to our syntax editor. And here is our MANCOVA. So again, see how I've labeled it just so I can find it again and know which one runs for which thing. So this is the syntax that they have for you hold on. This in the 5th edition is page 297. It's in table 7.25, which maybe in the 6th edition is just table 25. You see at the top there is a syntax, and it matches this exactly. So I just went ahead and typed that exact thing into this editor. So when you go ahead and do that and you're ready to run it, you just make sure your cursor's in the right spot and you go ahead and click run. And now I will minimize our editor again, opening up our output. And here is where we're going to have a lot to dig through. But remember what we started off saying in this video, what we're asking is, are there differences between the two groups or interactions of the groups, right? So femininity and masculinity, and then the interaction of those things. Where are there differences, and if so, where do they lie? So that's really going to lead us down kind of a path now of our main analysis. So the first thing we're looking at is our independent variables. And so you can kind of skip this top part here. That's not going to tell us anything we need to know. And actually, I'm noticing that the boxes M here for the MANCOVA is the same. So that's also, maybe we didn't need to look at that one on the first one, but it's there. It's the same, so that's good. All right, so we see here our 3 dependent variables and our 3 covariates, and they are correct, so we know we did the syntax right. And I mean, if you did the syntax wrong, it would show you an error message. So if you typed something in wrong, that's how you would know. So you just go back and find what your mistake was. So let's see here. We don't need these correlations. So I'm looking for the one that talks about, we're going to come back to this box in a second. There's a, we're going to come back to this. Here we are. Here is where you see it says effect fem by mask, because our first question is, are there differences based on femininity or masculinity on the combined dependent variables adjusting for the covariates? So this is a broad overall picture of the question. We're just looking for significance at this point, and then we're going to ask, where is that significance? So first, this interaction of femininity and masculinity, is that significant? And we go over here to significance of F, no. It is not significant. So that just means that the interaction of femininity and masculinity there's no differences on the dependent variables for those. It doesn't influence the dependent variables at all. So now we're going to keep going down, and we're going to look for, and by the way, sorry, jumped screen here. I'll scroll down to where we were. Okay, so fem by mass. If it's not significant here in this top one, then it's not going to be significant in the univariate tests or in the step-down tests. So all of this not significant. Now we'll look at masculinity just by itself. And here we see it is significant. We don't know what that means yet, other than we just know that the combination, there is a relationship between masculinity and the combination of the dependent variables. So we're going to find out which ones are significant right underneath here. And we see that, okay, masculinity was significantly related to self-esteem and introversion, extroversion. Now that's on the univariate test. So that means that it was as if it was just looking at the masculinity groups and the differences between the low and high masculinity in self-esteem all by itself and introversion, extroversion all by itself. Those things were significant. So there are significant differences between the low and high masculinity groups there. But neuroticism is not significant, 0.193. So that one, there is not a significant difference between those two masculinity groups. Now, the step-down tests are the ones that control for the other variables in the order we put them in. So esteem, then introversion, extroversion, and then neuroticism. And so we can see that esteem, again, was significant, and introversion, extroversion was significant. So that means when you adjust for the covariates and for, in the case of introversion, extroversion, we're also adjusting for self-esteem as if that were all things being equal. Is there still a difference? Yes, there is. Again, neuroticism, not significant. So that when you're assessing the DVs, what we've basically just talked through is kind of in the checklist, we have talked through the major analyses. We talked about the within cell correlations, and we just talked about the step down F and univariate F on masculinity. We're going to look at femininity next. But then I think for those of you who are in my class, in the assignment, actually the step down F and univariate F is in a section that's assessing the DVs. So I did not like the order of that, and I think you could probably change the order of the assignment if you want, but that is in like a little separate bullet point. But that's what we just did, so that's what we're just talking about, and we're continuing on with that. But basically, the overall effect is the one that says, okay, there are differences, and then, so that's okay. Masculinity is significant. We don't know on which variables it's significant, so we look down here, and the univariate tells us, okay, yep, those are significant. And even when you control for self-esteem, introversion, extroversion is still significant. Now we go down to femininity here, and it is significant as well. So we see the overall femininity, low or high, has something to do with the combination of DVs, but let's look down at the univariate tests. Okay, it's significantly related to self-esteem and introversion, extroversion if we were only just looking at those as univariate tests. But when we control for self-esteem in this step-down test, introversion, extroversion is not significant anymore. So that means that we're just looking at this one 0.002, that significance level. Now, one thing that when you do the write-up, and the book shows you the example of how to note these things in APA format, you need to note the step-down F or the univariate F right here. Now, esteem is the same for both of those because that's the same calculation. You didn't add anything that you're controlling for self-esteem because of the order of priority we put it in. But you are controlling for self-esteem when you look at the introversion, extroversion, so that's why those are different. And I don't know why it keeps saying double click. Okay, so this is 5.83, and this is 3.76 if you round. And you see here that's not significant. And neuroticism is still not significant in either one. So that is the assessment of the dependent variables. And what we're going to do, again, we're still wanting to know, okay, how is it different? So, all right, high femininity or low femininity has something to do with self-esteem, but which one is it? If you're high on femininity and low on femininity, which one has a better or greater self-esteem? We still don't know. And that's what we're going to have to calculate later in our very last analysis, is the adjusted marginal means. And so that's what we're going to look at to find out the answer to that question. So how does femininity influence introversion or extroversion? We still don't know. Same with masculinity. We know that masculinity is related to self-esteem and introversion, extroversion, but in what way? That's what the adjusted marginal means is going to tell us. Before we move on to that, we have one more piece to look at, and that is the covariates. So in the section, again, for my classmates, in the assignment where it talks about assessing the CVs, now we're going to look at more up on the top of the output. If you scroll back up, after the correlations here, right here, where it says effect within plus residual regression. So here we're looking at technically the Wilks, but all of them are significant. So we know that basically the combined dependent variables and the combined covariates have some kind of significant relationship. Again, we don't know what they are yet, but we just know we can keep looking because it's significant. If we go down here, just below it, it gives us part of our answer in this univariate F tests, and also in the step-down test, we can see that self-esteem has a relationship with the combination of covariates, and so does neuroticism, and same in the step-down test. So the introversion, extroversion is not significant. So that means that the combined effects of the covariates do not have a relationship with introversion, extroversion, but they do have an impact on self-esteem or neuroticism. And we still don't know exactly why yet, except for we did earlier talk about our correlations. And part of that we did learn from I'm not going to scroll all the way up, but part of it from our within cell correlations, we saw that there was a combined effect of esteem, neuroticism, and locus of control. So the locus of control covariate is the one that is playing the largest role there in the differences. Now scrolling down, we can see even more. Now you do need to report these B values, and you need to report the T value and the significance. So those are important, and the book does show that as an example. And so what we find here, now this is a little hard to read, so I was confused at first, but this is looking at the dependent variable of self-esteem and looking at which covariates play a role in self-esteem. So actually, what I said about the within-cell correlations might have led you astray. We know that there is a combined effect of esteem, neuroticism, and locus of control. But right here, we're actually asking and assessing for the covariates, what covariates play a role in impacting self-esteem. So we see here the significance on locus of control. Perhaps that's not surprising given our correlations, but then also attitudes towards the role of women is significant here. So you'd want to pay attention to those two B values and T values, and you'd have to report them and note that they are both lower than 0.001, or in this case equal to 0.001. And we see that socioeconomic status did not have any kind of relationship with self-esteem. So now we're going to look here. It says dependent variable introversion, extroversion. And the spacing on this, it makes it confusing to read, but now you're going to look below, and that's going to tell you which covariates had any kind of relationship with introversion, extroversion. Now, there's no significance here. This should not be surprising because up here, introversion, extroversion had no significance anyway. So obviously, if you break it down, if it wasn't significant in the first place, you're not going to find significance when you break it down. So that's obvious. And then now here in the dependent variable of neuroticism, which of the covariates had some kind of relationship with neuroticism? Looks like just locus of control here, and not significant on attitudes of the roles of women or socioeconomic. So you see that none of these were influenced, none of the dependent variables were influenced at all by socioeconomic status. And so that is basically a useless variable. It doesn't have anything to do with the other things we're measuring. So that's the assessment of the covariates and what impact they're having on the dependent variables specifically. So now we're going to look at the adjusted marginal means, and that's actually the last piece that we have, other than effect sizes. I mentioned that for the effect sizes, the book mentions that file, and you can plug in F values and degrees of freedom, and it will spit out for you the effect sizes that they have. I couldn't figure out, I tried to like copy and paste the little algorithm into my syntax editor, but it wouldn't copy and then paste. So I just believed them with the book. So the effect size is a multivariate effect. You're not going to find this on any of your outputs. You just have to go by what the book says. It's 0.10, and they say a kind of moderate effect. All the other effects were small. I think femininity was like 0.04 or something like that, and masculinity overall was a small effect as well. But the effect of self-esteem, the effect of masculinity on self-esteem was 0.15. That was the highest, so that was a moderate effect. So whether you have high or low masculinity has the strongest effect on whether or not you have a higher or lower self-esteem. And so you can look, let me see what pages the effect sizes are described on, just so I can give that to you. And you'll see the assessing covariates and assessing DVs in section 7.6.3 on page 296 in the 5th edition. In the 6th edition, that might be section 6.3 and 6.31, 6.32. So that's what we just went over. But I'm looking for the effect sizes. It's mentioned on page 300. And you're going to have to look for the other values because I am not seeing them right at the moment. Oh, here we go. In the very top paragraph on page 296 in section 7.6.3, it notes the effect sizes and confidence intervals, which you will need to report. You enter the F values of the Palais values if you could get that program to run. And so that's where it says it. In assessing covariates, it talks about the 0.10 effect size. That's the kind of overall multivariate effect. And looking for anywhere else that it talks about that. It's kind of mixed into their discussion. And you can also read their results section, and it does give the numbers in there too. All right, so moving on from effect sizes, the very last thing we need to do is the adjusted marginal means. And so I will open up my syntax editor again. And here they give the syntax for this on page 290, which is table 7.21, or maybe in the 6th edition, it's table 21. And this is looking specifically at where we found significance before. So for femininity, there was significance on self-esteem in the step down and in the univariate test. And for just the univariate test, there was femininity with introversion, extroversion. And then for masculinity, there was significance univariately and in the step-down test for self-esteem and introversion, extroversion. So those are the adjusted marginal means that's going to basically tell us if we control for everything else. So if everything else were equal for every single person, what would the new means for the masculine groups and the feminine groups be? That's what the adjusted marginal means is going to tell us. And so here, again, I have the syntax that I typed in from the book on table 21 or 7.21. And so if you have typed it in, you can just put your cursor right there at the beginning of that and go ahead and actually, I'm trying to think, because I think I combined two of them that they talked about, and I might have kind of ended up with something extra. You see where I have this design cons plus fem? That's not in the original one. The original ends with right here, this. There would be a period right there. I think that I added that line because I was combining another bit of information that they had, but now I can't find where I did that. So in order to not confuse you, because I actually was confused by that, so I'm going to just erase that. So this is exactly what the book has there. And yeah, I don't know where I got that other idea from. Okay, so we're going to just run this exactly as the book has it. And what removing that little line did is we are not looking at femininity and introversion, extroversion, because that was only significant on the univariate test. So we're just forgetting about that. We're just looking at the step down significance. Femininity was significantly related to self-esteem. Masculinity was significantly related to self-esteem and introversion, extroversion. So this estimated marginal means MANOVA is going to give us what the means would be if everything were otherwise equal. I'm going to save my syntax since I changed it and go ahead and hit run. And this is our very last analysis here. So we're going to look down here and we are going to look at, now I found this very confusing, but if you look at parameter 1 and 2 here, that's going to tell you which, whether it was high femininity or low femininity, high masculinity, low. So this one is looking at the levels of esteem, adjusting for the covariates, and it's looking at, let me see, if we go to our data set and we go to the variable view, I think this is how we'll know that 1 is low on femininity and 2 is high. So if we go back to our output, 1 is low and 2 is high. So I'm trying to see if that's, yeah, that is what they have here. Sorry, I'm confused. I had this all figured out and now I don't remember it fully. So bear with me here and maybe you're figuring it out too. I try to go slowly in these videos so you have a minute to look at this. Okay, well, I know that this is one of the ones that was important right here. 14.22 and 16.92 if we round. Now, this is parameter 2 and 3. I would not be able to decipher that because as we just looked in our data set, we were hoping that 1 and 2 meant high and low. But the book explains it in their final report, and I just had to kind of decipher from their discussion what was high and low. So essentially on page, hold on. Oh, that's what I did. I combined that marginal means calculation was a combination. I tried to add in the design equal con plus fem from table 7.31. And that's because that one was only significant on the univariate analysis. So I just tacked that extra design on there because the whole other rest of it was the same. So yeah. So you should, I think I just told you the wrong thing. I think I might have been looking at the wrong page. The syntax that we just did for the estimated marginal means, or they're calling it adjusted marginal means, is table 7.30 or table 30 in the new 6th edition, and table 7.31. Those are the ones I combined, and that's why I had previously gotten a slightly different. The output's the same. I just had it all in one spot. So you could just add that last line on and do it all at once. But yeah, I found their explanation helpful when trying to figure out low masculinity and high masculinity. But here, if this is femininity, in their report on page 306, the last bit of their report, it talks about this. And so it says greater self-esteem was found among higher masculinity women. And this is the 16.92 value that they give. So that was the lower masculinity women. So it's femininity based on low masculinity as opposed to femininity based on high femininity. And so basically what we see is that we remember that the self-esteem scale, lower values means greater self-esteem. So we have that higher masculinity women having this value of 14.22. And that means that their self-esteem was higher because they had a lower score. That's confusing, but it just seems to be the way the scale was measured. If you have a low score, you have a better self-esteem. So for the higher masculinity women, I'm sorry, for the lower masculinity women, the self-esteem score was higher, and that means it was worse. So really follow along in their explanation, in their report. It's where they put it all together in one spot. It was the only way that I could understand what the significances were. But ultimately, it is what kind of reveals something potentially interesting, which is just thinking about the ways in which sexual identification or, higher masculinity, lower masculinity, or that kind of thing affects your self-esteem. So what they were finding was that higher masculinity women have greater self-esteem. And also on the introversion extroversion, if we scroll down here, here's introvert extrovert scale. You see here these coefficients. So, and higher the score here means greater level of extroversion. So here, I'm just looking at their report here. If they say this one, they also talk about the effect sizes here. Yeah, the women scoring higher on the masculinity scale were more extroverted. So this must be higher masculinity is 12.47 is their extroversion scale, which is higher. So the lower masculinity women had a lower extroversion score. You do want to pay attention to the standard error as well. That is something you need to report. You can ignore the rest of that. Okay, and looking down here, that's it. So there is an additional output that I would have gotten if I did the extra, and that's listed in table 7.31 if you want to do that. They did not include that in their report, the difference in the 11.91 coefficient and the 11.10 coefficient. So I'm not sure if they found that to be not different or what, but that would be the univariate introversion extroversion analysis. There should be one more comparison. We did that one. We did that one. Did we miss one up here? Yeah, right here. So this was on esteem, self-esteem. And so I think this is the femininity one. Let me look at what they say on their results. I don't know if they reported this one. I didn't fully understand why they didn't report some of them, but this one, 16.72 and 15.35. I don't see that in their little report here. So I did include that in mine. Let me just open my report up and look at what I said. This is the explanation of the estimated marginal means. I explain what that is, so you can pause if you want to read it, but I'm just going to go down here. Higher masculinity women have greater self-esteem. We talked about that. The introversion extroversion. This was the high masculinity and low masculinity women. The high femininity women showed higher self-esteem. Oh, I might have made a mistake on that too, because as you recall, the higher the self-esteem score, the worse it is. So actually, I'm going to have to change that. High femininity women showed lower self-esteem. Can that be right? I'm going to have to double check that. Don't write that down because I might have to double check that. As you can see, and I'm sure as you're experiencing, this is difficult when you don't know, you're not that familiar with the data set because it's harder to interpret. So, but if they have a higher self-esteem score, then we're saying that's worse. So I'm going to go ahead and leave that then with high femininity women showed lower self-esteem. And then the piece that we didn't run that you could run if you wanted to do the syntax in table 7.30 on page 301 in the 5th edition, you could get this last output, which they have there in the book underneath it, 7.31. I'm sorry, 7.31. This is the 11.91 and 11.1. So that would be the higher femininity had slightly higher extroversion than the lower femininity. So drawing conclusions about all of this, they did kind of take a stab at that. And here I describe the pooled within cell correlations. I feel like I have one more step to do, and I'm sorry I didn't do this before the video. Maybe I'll pause it and figure it out and come back to it. But essentially, if I made a little chart of the differences, which I did somewhere right down there. Let me see if my chart helped me. I think I jotted down which was high and low and what those meant. So yeah, if you think back to our 4 groups, let's save on this. Let's save our output. If you think back to our 4 groups that we had undifferentiated, feminine, masculine, and androgynous, we'd have to take those marginal means and kind of put them into those groups again to look at, okay, the high masculinity and high femininity was the androgynous group. High masculinity and low femininity was the masculine group. Low femininity and low masculinity was undifferentiated. And high femininity and low masculinity was the feminine group. So we could put these marginal means kind of into those groups and categories based on what we're finding here. If it was high masculinity or low masculinity and high femininity, particularly on self-esteem, we could do this. And but I suppose with the introversion, extroversion, again, it's the univariate significance, but you could possibly do that for femininity as well. And essentially come to your own conclusions about whether you think that means anything, particularly because the effect sizes, to me, were not that great. They said some of them were moderate, and really masculinity on self-esteem was the strongest effect, and that was only moderate. So I don't know that I'd be like, publishing a study that's like groundbreaking or anything, but for the purposes of this assignment, we are done, and I hope that all made sense. Thanks for watching, and comment on the YouTube channel if you have any questions or thoughts. Thanks so much, and I'll see you next time.